Hello, I welcome you all. The problem reads if block B is moving down with a velocity VB and has an acceleration AB, determine the velocity and the acceleration of block A in terms of the parameters shown. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by RC Benam. So let's have our datum. So we have that point there and that point as our datum. So let's say let me just use black. So we have our datum, which is this one here and this one. Okay, there we go. Okay, all right, so we are going to call this SB. This is our positive direction and this one is our positive direction. So now let's relate the length of AB, the rope AB that goes over the pulley, and we have this constant here, okay, which I'm not going to, wow, you can call it C. Okay, so the other thing is H. Okay, H and C are constants. All right, these are constants. All right, so let's start. So we have H. We have SA squared plus H squared. Okay, to the power half plus B is equal to L. Okay, plus C is equal to L. Let's take the first derivative. Let's use the power rule for this case. So we are going to have half there. Okay, the inside remains the way it is, and then this becomes to the power half. That's 1 minus half minus 1. Then the inside is 2 SA dot, then H is just a 0, C is a 0, and L is a 0. Okay, sorry. Then we have SB plus SB dot, then C is a 0 and L. Okay, so we have this equation, and we can simplify this further. We cancel out the 2 there, so this just gives us SA squared plus H2 squared to the power minus 1 over 2 SA dot plus SB dot equal to 0. Okay, so given that VA given that SA dot is equal to VA and SB dot is equal to VB, okay, and SA double dot is equal to AA acceleration, and SB double dot is equal to AB. So writing this, we want to make SA, want to find the velocity. So make SA subject to formula. So say SA dot is equal to minus SB dot SB dot divided by SA squared plus H2 squared to the power minus 1 over 2 SA. Okay, so let's rewrite this one. This one becomes equal to minus SB dot, this part comes up, SA squared plus HA to the power half, then divided by SA. Right, so we can factor out. We can also say SA is just equal to SA dot is equal to minus SB. You factor out, that becomes SA. So we say SA squared, factor out, we say plus H squared divided by SA. Alright, so something like that. The reason we are doing this is to just make it a bit easier when it comes to the derivative. Okay, so this is therefore going to be equal to Sm SB to the power half, like so, and everything divided by SA. It just becomes equal to this one becomes equal to, we can factor it outside, SB minus SB, then SA, then SA, then we have a 1 plus H squared divided by SA squared to the power half divided by SA. So this and this cancels out, and therefore what we have is, when they cancel out, we only have minus SB, minus SB, 1 plus H squared divided by SA squared, SA squared, okay, to the power half. Okay, so we have this one. So let's find the double derivative, second derivative, so that we find acceleration. So we'll say SA, our SA double dot, okay, of this just becomes minus SB dot, right, minus SB dot, we are using product rule here. Okay, so we find the derivative of one function and then leave the other one constant. Then we say plus, since there's a minus here, so this will be plus minus SB. Okay, then we work on this one now, SB, then the half, using power rule, this half comes down, then we'll have the 1 plus H squared divided by SA squared, right, to the power minus 1 over 2. Then the inside of this, the inside 1 is just a 0. This one we are going to use the quotient rule. Remember the quotient rule? So it just becomes SA squared times 0. So this just becomes a 0 here, because H is a constant, then minus minus H2, then we have a 2 times SA, then SA dot. Okay, everything quotient rule, remember, is SA to the power 4, right? Great. So therefore SA double dot, writing this, simplifying it, just becomes these 2 and 2 cancels, the minus and the minus cancels, so only have something like this: 1 plus h squared over sa squared to the power half. Okay, and then here we'll have a plus. The 2 and the 2 cancels out, then we'll have sb like this. Then 1 plus h squared sa squared okay, to the power minus 1 over 2, and then times h squared. Okay, one s there cancels out, h squared s, and then we here we remain with the 3 like so. So then sa divided by h to the power 3. Okay, right, so that's about it. Let's work out now to write this. So we have VA now using this equation. We have our VA, which is equal to SA dot, which is just equal to minus SB 1 plus h squared divided by okay, let me just use the root minus SB square root of 1 plus h squared divided by h squared like so. Okay, which can also be just written as SB square root of 1 plus h squared divided by sa squared. Right, so let's just write that like so. Okay, let me use black. All right, and then we know that the direction of our block A is in this direction like so, no, in this other direction like so. Okay, so this is the direction. Okay, so this is in this direction, right? Then for acceleration, which is just a this a which is s double dot sa double dot, which is just going to be equal to we have this equation already here, so this just becomes minus vb, okay, minus vb square root, okay, square root of 1 plus h squared divided by sa squared, okay, then plus we have sp there. This one here, it is s dot, okay, this one here. So this becomes our s dot, we know is va, then sb, then h squared, right, and everything divided by, we just take it up a little bit, everything, so we have this, then divided by sa to the power 3, then square root of 1 plus h squared divided by sa squared. Right, the direction also is in this direction. Great, I think we are done. Let's just outline this. So this is the final solution. This is the velocity of block A. Alright, so I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.